And we are live. Okay, this is kind of funny, but Heather couldn't be here this week, and it's my turn to host this Skillshare session with Rita Zagoni. Rita is a programmer who is doing crazy things as a fellow with School of Data. She has a social science and philosophy background, which we love about her. And now she's going to teach us a lot about database design. What does that mean? Many times when we're doing trainings with School of Data, we use databases that are ready, like you download it from some site. But other times we have to do this gathering of data. And we've had Skillshares in the past about how to work with offline data and topics like this. And so when you're trying to translate this into an online format, or well, a digital format, there are some things you should take into consideration when you're designing this database. And this is what Rita will be speaking about today. If you're watching this on YouTube, please, and you have any questions, please leave them on the comments box, and I will have Rita answer them. If you're following this on Twitter, then just tweet at School of Data or Escuela de Datos if you're speaking Spanish, and we will take a look at those questions for you. This is a part, as I said, of the Skillshares sessions that School of Data Fellows are running all over the world, and you can find in this YouTube channel all the other past sessions, and you will be able to find sessions in the future. So I will leave you with Rita now.
Hi everyone. So yes, we're going to talk about today a bit about database design. It is going to be quite a practical introduction. So I have a spreadsheet prepared, and we're going to do some step-by-step database structuring and data cleaning. And this is going to be, so these are mostly going to be guidelines and best practices. So in my view, nothing is set in stone, and much of how you approach designing a database depends on your data and what you would like to do with the data, what your goals are. So what's a database? Basically, it's just data, a collection of data in an organized form. And it makes it easy to store your data in a structured way and to manipulate it as easily as possible. So in order to design a good database, you have to know your data, and you have to know what you would like to achieve with it. I have a PowerPoint to make this a bit more easily followable. So let's see. Okay. I mentioned that the important thing is to know what your goals are. So let's take this, or let's break this down a little bit. What can be your goals with the data? In terms of usage, there are two basic types of databases. The one is for creating, which is mainly for creating data, updating, and deleting records. So if you think a typical business application like an online shop. In an online shop, you've got products, a bunch of products, which there are new ones introduced, there are others which leave the market, or which you don't sell anymore. You've got customers registering, they're placing orders and modifying orders and deleting them, and you fulfill those orders and close them. So there's a lot of modification going on. Another type of usage of databases is when you have your data set and you don't plan to modify it that much, but mainly you want to do analysis based on the data. You want to query your data and find patterns and reorganize and summarize. And I will mostly talk about this latter usage. So the most basic tool for this kind of data manipulation analysis is spreadsheets. Well, in many cases, spreadsheets are not even considered a real database. So if you're talking to a developer, then in most cases they will mean a database management system by a database and not a spreadsheet. What are the main differences? So spreadsheets can be accessed by one user at a time. So you have a spreadsheet, it's on your computer, and if you want to collaborate on the sheet, that's not very easy to achieve. While with a database management system, and it's run on servers, and multiple users can access it at the same time. Also, spreadsheets have, well, quite serious size limits. Excel version 2007 can have about 1 million rows, but it tends to get really slow at a smaller size. So if you have that much data, you better use a database management system. And as I mentioned, the spreadsheets are mainly good to store data for querying, and in the database, and it is quite difficult to make modifications and track them, and to keep your data consistent if you do a lot of modifications in a spreadsheet. However, in a database management system, it's much easier to create and update and delete and modify your data, and keep the dataset consistent. A spreadsheet can accommodate a flat database, which is basically just one table of data. And in a database management system, you can have so-called relational databases, in which tables are organized and can be related to each other, can be joined. So
Rita, sorry for interrupting you.
Yeah.
But can you give like a few examples on how it looks in practice? Like what it looks like a relational database.
I will have an example at the end, but I will show you right away. I will just switch to the other screen to share. Okay.
Because I feel like we've all seen flat spreadsheets, but maybe there are some people who haven't seen relational ones.
I'm planning to go into a bit more detail at the end, but I will show you how it looks like in a spreadsheet. So in this case, you have this is a simple database with two tables. You have a company table, in which you have an ID of the company and some fields for it, like its name, type, and state. And in the other table, you refer to the company by that ID it has in the main company table. So you don't have to list all the information. But in the other table, you just, if you want to refer to a company, you refer to its ID. So this is the main propriety of relational databases, that you can, in such a way, you can link two tables together.
Awesome.
Yeah, does this sound good? I will explain it a bit more detailed way at the end.
Perfect.
Okay. Perfect. Cool. So yeah. So why I will keep keep the spreadsheet open. So this is gonna be our first flat database. So as Maria mentioned at the beginning, so it is important to know a bit about databases, because in some cases you have a complete database and complete data set, and you don't have to do much with it besides start using it. But in many cases, if you collect your own data, maybe through surveys, or if you scrape data from the internet, then you might have to build your own database from scratch. And it is a good idea to really think it through at the beginning, because it is quite tedious to change the structure once you established it. So first thing, if you have your data, look at the size. So if it's really huge, if it's more than a million rows, that's a simple decision. You have to go with something else in a spreadsheet. And it really, you get a quite low performance after a few 100,000 records. And then you should think about the purpose. So at first, in quite general terms, what the database stores, and what you're planning to use it for. It can be a good idea to write down the purpose of the database on paper, like for this one. The database stores information on lobby firm spendings, and we plan to use it for analysis. So at this occasion, I will present a bit this spreadsheet we're going to be using. The data is mainly from the site Open Secrets, and it is a database of companies. Companies' lobby spendings by year. So this is in the amount column, the sum of the company's spending in each year, and the raw data is from there. I've made a few modifications for like presentation purposes, so this is not accurate, and I've made most of the company types up. So this is not the database you find there, but the basic structure is from Open Secrets. It is also, besides the general purpose, it's also a good idea to write down or think about what kind of analysis you would like to do with the data. So maybe you will want to know in each year which company spent the most. So to have an overview of what kind of queries and what kind of analysis you would like to do with the data. Let's talk a little bit about the structure of a table. I know you're familiar with it, but just to have a few key concepts. So this this is one table of data, and it's a matrix of rows and columns, and each row is also called record. A record is just some meaningful and consistent way to combine information. So in this case, it's in each year we have one spending amount for each company. So for each year, each company appears only once with the sum of their yearly lobby spending. And in each column you have, or in each field you have one single item of information, and that item, that information, like the company name, the type, the amount of spending, and the year of spending, they appear in every record, and they appear in the same order. So it's important to keep in mind that a record can contain data only about one specific item. So in any case, you should not mix, for example, spendings of two companies in one record. And also, a record has to store all the available information of that specific item. And about the columns, it's important to have the headers for each, the name in the top field. So now, as we have the overview, we can go to some structuring and refining and cleaning of the data. A very important principle to keep in mind is it's a good idea to store information in the smallest meaningful logical parts at a quite granular level. What does that mean? So in this case, we have the company names, and at the end you have the type of the company. So initially it was just in the database it was just a company name, but I split the type of the company to a separate column. So this gives much more power and possibility for analysis. So you can now query by type. Is, for example, you can check which type of company has spent most on lobbying, for example. So this is a good idea to do this splitting up at the beginning, because it is much easier to combine this information. And but if you don't do this breaking up at the beginning, it will be much more difficult to use the parts later in the analysis. The next step is to check for duplicate entries. They not only waste space, but they also increase the likelihood of errors and of having inconsistencies. It's quite easy to do it in Google Spreadsheets and also in Excel. In Google Spreadsheets, you have a function called unique, and you just have to specify the columns, in this case from A to D, and we can see at the length that it's a bit shorter, so it seems we had a few duplicate values.
That's super useful.
Yeah, and you can just delete the initial count. Oops, yeah, nope. That's the second step first. So these are defined by the function. So firstly, I copy the new values and paste with paste special, and I do paste values only. So in this case, I won't have the function in the background. I only have the visible values. And normally, if I delete, yeah, if I delete, I have the values. Okay, and I format these to make it more visible. So that's a nice trick, and that's something important you should do quite at the beginning. Other thing which might cause confusion if you have some values in different forms. For example, for the company type. Um, you have, for example, LLP, limited liability, partnership in different forms, and association in full length and with abbreviation. And this also, if you're doing a query, then if you query for example, ESOP, then you won't have all your records. So you can check it with a filter. If you put a filter, you can see what kind of values you have, and it's quite easy to get rid of the wrong ones. For example, I would like to use the abbreviated form and get rid of the full one. So I do find and replace, and I would like to in this one and replace it with this one in the sheet. Matching case, and it's standard. Now it's standardized, and you have the same form, the same value for every record. And I should do the same for all the differing types, which I can check here. Another thing, this is starting to look good, but there are a few things which can still cause confusion. The amount cell. I have the dollar sign in every cell, but in this case, it is not recognized as a number. So if I, for example, I would like to sum up three values, I get 0 because they are interpreted as text. So I will have to get rid of those dollar signs. We're going to use the same option, find it, replace, and we're going to check for dollar sign and replace it with nothing. Yes, much better. So if you want to sum up first few values, then it works now. But still, yeah.
Sir,
Something that is worth adding here is
we're getting feedback.
Sorry, I didn't hear you.
Okay, great. Something that is worth adding here is that on School of Data, or at the courses section, You can find a lot on formatting, like how to make sure that your values in a spreadsheet have the right format so that the whole $sign thing won't happen to you. That's it.
Yeah, exactly. It's an important step, and it's a bit of data cleaning, but also for design, it is worth mentioning because when you design a database, it is good if you know in advance what kind of values each cell has, and in a database management system, you also have to give the type of value at the beginning when you create a database, and you have to decide whether it will be text or character sequence or integers or whatnot. So this kind of standardization is an important point. Another principle is to avoid multiple data in one cell, which we have in a few cases. For example, it might be the case that there was one value for the first half of the year and another value for the second. And this is definitely not good design, and you won't be able to work with these kinds of cells at all. The same problem comes up if you want to sum that up. So you have to split them, and it's also easy to do it in a spreadsheet. I had two columns for the two new values, and we have the split function, and now we choose the text we would like to split, and the delimiter by which we would like to split it. So in this case, we have the slash sign, which delimits, which separates the two values. So I'm going to include the slash. And that's it. So in this case, we just had one value. And with a double click, I can fill the cells with the function, and we can see that it worked quite nicely, and it split at every cell. When we had two values, we split it into two, except when the cell was blank. So we can do the same trick as before. So copy the content and do a paste special and paste values only. So we don't have it's not the function we have in the cell, but the result values, and get rid of the original code. And that's it. And we can say like amount for the first half of the year, and the amount for the second half, or something like that. Yeah, that's it. Okay, what else? We have this error here, which is caused by empty cells, or more precisely, empty row in the database. So it is important to eliminate the empty rows. Many spreadsheet applications like Excel and also Google spreadsheets interpret empty rows or sometimes empty cells at the end of the table, so they regard it as at the end of the table. And also, if you're running functions, they might cause a problem. So it's easy to do with filtering. So like, nope. I will add filter No. And add the filter for every field, and we'll filter for blanks. And we see that we have a blank row here with the function causing the error, so we can just delete the row, clear the filter, so select everything again, and it's clean now. Yeah, here we had an empty cell. So the next thing is to check empty cells. So when we have some values in a row, but not everything is filled. So it is not necessarily bad to have empty cells. So it is not necessarily wrong, but they can interfere with a lot of functions. For example, when we use it here, I'm gonna delete that. But for example, if you use the average function, it evaluates zeros and empty cells differently. So if you have an empty cell, then the average function is not going to take that account at all. But if you have a zero in it, then it's gonna be treated as a valid value, and it's gonna decrease the average. So it's important to be conscious whether you have a missing value, whether you have zero, whether you have an empty string. So I'm going to show you another function which fills the empty cells. So I'm going to show it here. So insert a new column, and it's going to be a conditional function, and we'll check if cell is blank. So the adjacent cell, we're going to check if the cell is blank, and if it is, then we're going to put not applicable instead. And if it's not empty, then we'll leave the value of the cell as it was. Let's see. Yeah, here we have an empty one. So I have to I have to fill up down to the bottom. So here we had a missing value for the amount, and in the new column we replaced it with a not applicable. So just as before, I copy and paste the values, and I do delete the original one. So, and this should be repeated for the remaining columns, of course, but I'm not going to do that here. We're going to also talk a little bit about relational databases, and for that, it's important to have a unique ID for each record, and it's not a bad idea either for a simple flat database to be able to identify every single record with a unique number. So we're going to insert an ID column, and it's just going to be simply a sequence of numbers, and we're going to use this automatic fill, with double clicking, and it filled up with a unique ID all our records. And a few tips about the placement of the table in the spreadsheet. Usually, people start a table at A1. It's of course it's visually sometimes good, but at times you have a lot of functions and summing values, summarization values, and in that case, we place those usually at the end of the table and the end of the columns. But sometimes um, it's easier to, if you use them a lot, it's easier to place them in the beginning and leave a few rows and a few columns at the beginning, and you can put your, for example, your filter criteria or your most used functions at the top. And also for easier handling of the database, sometimes it's good to use multiple sheets. For either, if you have a lot of functions, you can put the functions on a separate sheet, or labels or explanations, so you don't have to cram up everything at one sheet. So this is the what I wanted to tell about this basic flat spreadsheet design. And I would like to tell a few concepts about relational databases. So if you have a lot of data, or it's very complex, or if you have to do a lot of modifications, or if you have to collaborate with people, then it's a good idea to use a database management system instead of a spreadsheet. And of these, the relational databases are by far the most prevalent type. So if you talk to developers, they usually mean relational database by that. In this case, for this data, what would be a use case for a relational database? For example, if for each company you had additional data as the state they're registered in, the zip code, maybe if you had additional columns for the address, that's a lot of data for one company, and the companies are appearing repeatedly. Then you would replicate the same information, the same address information again and again, and that would take up a lot of space, and also it would be much more difficult to handle. So in this case, for example, it would be a good idea to create two different tables. So we would have a company table, which wouldn't consist of anything else, only the companies, the company information, name, the type, the state, and the zip code. And in this case, it's very important that all of the companies would have a unique identifier, which in this context it is called the primary key, the key for the companies. And in other table, you would have the lobby spending information. They will also have an ID, but also you could track the company, the spent amount, and the year, and the company would be referred by their unique ID. So nothing else in the lobby table. only the company ID, and you can, by this identifier, which corresponds to the unique ID of the company, you can identify the companies. So if you query the table, or so if you're using and manipulating the data, you can join these two tables together by the company ID. So this is here the primary key, and the company ID is called a foreign key if it is referenced in the other table. So that would be a very basic relational database design, and again, this was our initial flat spreadsheet design when we had all the information in one table, and we split it into a company table and a lobby table. So I think that these were the main points I wanted to tell about. So now is the time for questions.
I'm checking if there are any questions on Twitter or the Hangout itself. No, I don't think we have any questions here. I'm thinking for people watching this in the future, if if anybody watches this in the future and they have questions, then at the end we will be giving Rita's contact information and some helpful links. But meanwhile, I think, Rita, you can continue.
Thanks. So I will switch back to the PowerPoint. So I will. I haven't used this much during the presentation, but basically the main points are listed here. So I will also share this by the video and also the additional notes. I guess that could be useful. So yeah, that's it.
Excellent.
Excellent.
Okay, then thanks a lot, and I don't know what will be the next Skillshare, but stay tuned.
And
And
I'm going to say something. You can mute your
can
microphone.
you use your microphone?
Excellent. So my connection is bouncing now. That's excellent. Okay. Rita, a good medium to reach her. Otherwise, you can leave questions as comments in this YouTube video, and you can also tweet them. We're at School of Data, and we will leave in the comments box not in the comments box, in the description box, some useful links like that has used today, some links to School of Data communities, like there's an Ask forum, so I will link to that. And also, well, the next Skillshare will be on impact assessment with Rahul from the School of Data and OKF Central, and all. And that's going to be next Tuesday. So, and thank you.